Hey guys,
Hello!
it's Tuesday and
Yes.
time for another update from the lovely Addie here and her um, uh, first steps into programming microcontrollers.
That is correct. So it's been like about a month since I last touched the the heart LED project.
Oh, from the Telltale Heart video, she was
Correct.
making like a simulation of an actual human heartbeat
Correct.
in blinking LEDs, because
Correct.
that's how she rolls.
Right. And that was nice and cool, and that was like one of my first coding projects. And someone on Hackaday kind of complained, I guess, that I didn't use the proper times, like the proper number of milliseconds involved in the rhythms. So I decided that I would go a little overboard and do 12 well, I would say significantly anatomically or physiologically accurate timings of different heart rhythms. And so I have the first six done so far: sinus rhythm, sinus brady, sinus tachy, atrial fib, atrial flutter, and supraventricular tachycardia.
So, in other words, medical students, don't mess with the Addy. What?
So anyway, I mean that's cool. It's good
Well,
motivation to
let's see
improve.
it.
Okay.
And if you could explain how what you had to learn in order to actually do the programming for this, because it's very much more complicated than what you were doing before.
Right. So it looks exactly the same as before, in terms of just a lub dub. But in order to get the timing of it correct, I obviously needed to know how long the PR intervals, the
Well, for
key
those of us who
segments.
aren't experts, what do the orange and blue lights represent?
The orange represents when the first electrical impulse in the heart occurs, like at the sinal atrial node. And then the blue one is where the I guess the impulse is strongest at, in the ventricles. I guess that's the best way. That's the most lay way I can think
So this
of
is just
explaining
like
it.
two of the neurological features of it.
No, not neurological. It's electrical. Cardiac cells have an inherent electrical capability, like an inherent electrical, what's the word? Contractility to it.
Okay.
Yeah.
So it's
They're
not
electrical
it's not
cells
part of the
in your own
nervous
cells.
system. It's got its own little electrical system in there.
Yeah,
Now,
kind
does
of.
it use like a dual inline socket, or
I don't
is it
know.
like TTL logic levels?
It's more like parallel communication.
I see.
Yeah.
Okay, anyway.
We're gonna confuse everybody. So, anyway, it's easier if you think of it as the lub dub, even though the lub dub is the sound of the valves, but for ease of understanding, we'll just call it the lub dub. All right. One representing the atrial polarization and depolarization, and one representing the ventricular polarization and depolarization. Anyway, so this is sinus rhythm, and what I had to learn was that clock frequency, CLK, FREQ, is the system clock essentially on this board, and which is the Propeller Board of Education that we got
How
recently.
many literal cycles per second is that environmental variable? So, to figure out precise timing, she needed to know how many clocks occur in a literal second.
Right. Which is what?
80 million.
80 million? Yeah, so 80 million per second. And so what I did then was I took the clock frequency, I divided that by 1,000 so that I would get 1 millisecond.
Mm-hmm.
And then from the 1 millisecond, I if the PR interval required 120 milliseconds, I'd just do 120 times clock frequency divided by 1,000 and have that wait time be what I used. Anyway, so I have the code here, and so for sinus rhythm, I assumed the P segment, the P wave was 80 milliseconds, the PR interval was 100, QRS was 100 milliseconds, and the R to R interval minus the amount of time it took for the PQRS was about 720. And so here we go. And this is, I believe, either 60 or 80 beats per minute. I know it's somewhere in there, but anyway, okay, so I'll finally go to the next one. So sinus Brady is a rhythm that goes a bit slower. Pretty much everything about the P and the QRS are the same. It's just that the amount of time between each beat is different. So that's like around, I want to say 50 beats per minute. And then sinus tachycardia, which is higher, I think I made this for about 105.
That's what I look like after coffee.
Yeah.
Woohoo!
That's about 105 beats per minute, give or take. So, yeah. And the only thing that I changed there again was the amount of time between each of the PQRS complexes. So like sinus, say this was sinus rhythm, this is sinus Brady, this is sinus tachy. So it just happens more often. Now atrial fib, this one was kind of different because what happens in the heart is that you have your atrium and they're kind of quivering, and your ventricles...
In anticipation?
No, not in anticipation. More like stress, or because there's some sort of aberrant, somebody else is throwing a party in the atrium besides the sinoatrial node.
Wow.
Yeah.
That's rude.
Right. Well, yeah. So the atrium are going like this instead of a nice squeeze. And they're going like this. And they're sending a bajillion electrical impulses down towards the ventricles. But if the ventricles were to respond every single time they got an impulse, you'd probably get something like VFib. And the person would pass out because they're just not getting efficient blood sending. So, what I had to do was I had to have one cog of the propeller do this, and then have one cog randomly have the ventricles react to those electrical impulses, to quote electrical impulses. So, if we look at this...
Wow, that doesn't look good.
No, it's not. It's better that it's atrial fibrillation rather than ventricular fibrillation, because at least the ventricles have enough time to fill and then pump their blood.
Still.
Well, I know. So, yeah. And then it got easier because then we went to atrial flutter, which is actually more dangerous than atrial fibrillation. And atrial flutter is essentially, you have the atrium.
Oh, I can see the difference there.
Yeah, you can see the difference, right? It's actually like this
like
one
dubstep.
Kind of. What you can see is that this one's slightly different because it's 3 atrial pulses to every 1 ventricular pulse. You can tell the difference because it's a kind of an ordered PPP ventricle, and this one's a 3-to-1 conduction, and usually they vary between like a 2 to 4 conduction sort of thing. So the thing with atrial fib and atrial flutter is that with these rhythms you run the risk of getting clots, and that's because with atrial fib and flutter, it's causing a lot of turbulence in the atrium, and once that turbulent blood that may have developed clots get into the ventricles, with a good squeeze of the ventricles, those clots end up going to like the brain, to your lungs, to everywhere else. And that's when you end up with either potential heart attacks, strokes, pulmonary emboli.
And you're all programmers, so she's talking about you.
Right. So if you feel like a lot of palpitations, you can actually kind of tell what kind of rhythm you have. Like if you feel your pulse, your carotid pulse, if it's regular and steady when you're having your palpitations, then I don't know, but but if you start feeling that they're kind of irregular, then maybe wonder why you have these funny things.
Go eat a salad.
On. Right, go eat a salad. Okay, so that's A flutter.
I'm not a medical professional.
It is, by the way, I think one of the prettiest rhythms, although lethal.
That's
it's
terrible.
one of the prettiest rhythms to look at. Because it's like a sawtooth wave. It's like bloop, 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 bloop. Anyway, okay, so this is SVT, supraventricular tachycardia, and that's pretty much any type of fast heart rate that originates from the atrium as opposed to the ventricles. And I think I made this to be around 180 beats per minute, give or take, which is significantly higher than what you want. Normal range is between 60 and 100. We usually think about SVT when it gets, in our practice, like above 150 maybe, even 160 maybe, because AFib, sometimes you can get really rapid rates. I've seen up to 180. So anyway, so this is SVT, and it's really fast, and I hope you don't have this because you'd feel pretty crappy. And yeah, so this is the first half of the ones that I want to have made. What I'm gonna do is I'm gonna incorporate sounds. I'm gonna incorporate a little.
So the
knob.
next time we see an update on this, it won't be just like 2 little lights. It'll be more.
Well, I
fancy.
don't know. That I don't know, because I still have to code all of the other ventricular tachycardias and the first degrees and the bundle branches. So the bundle branch blocks, I should say. So we might see another video of just these 2 LEDs, but the third video should be, I think I want to put it into a nice little package of sorts and make it so that there's a knob where you can choose which one you have, and then you can see the representation and maybe even the beats per minute if I can figure out how to code it.
Yeah, doesn't sound like anything you can't figure out how to do.
We'll see.
And then you can like become a billionaire selling them to healthcare professionals so that they can like see blinking lights to explain heart rhythms.
Hey, that'd be a good idea. Okay, I'll do it. That'd be cool.
All right, so does that cover your progress there?
Yes, it does.
All right, excellent. Okay, I don't have anything for you guys today. This Friday video is going to be a special holiday video, so make sure you tune in for that.
Yes.
I'm working on a really, really big project that's taking me like a week and a half, so Friday after this Friday, I will have a big update for you guys. A very detailed, complicated thing that I've been messing with.
Right.
That'll be fun.
Yep. And next Tuesday you'll see the second half, or the second third of this project.
This development platform right here is a parallax propeller. Addie's learning how to program them. Just because we were very into like doing educational stuff, we are doing a podcast as she learns how to program the thing.
Right.
Because she wasn't a programmer to begin with. So Roy Eltham and myself are answering all her questions on a podcast, and that's how she's learning. So you guys can learn right along with her at firstspin.tv.
Correcto.
We just put up episode 5 today.
Yep.
So go check it out.
Sounds good.
All right. Okay, this week on Thursday, we're going to be putting online a new episode of Zombie Tech with Willow.
Yep. Willow Brew of Geeks Without Bounds.
Yeah.
Pretty cool organization.
Kind of a badass hacker chick.
Yep.
Yeah, she's pretty cool. We had a fun time talking to her. So make sure you head over to zombietech.tv and sign up for the RSS or iTunes, whatever.
Correcto.
And get that automatically on Thursday when we put it online. All right, I think that's it for us for this Tuesday edition of Toy Makers. Thanks for watching, and we'll see you guys Friday.
Bye.
Bye.
We post videos all the time, so don't forget to subscribe. And follow us on Twitter at TYMKRS.